Hello friends, today we'll discuss one more topic. It's called sulfur hexafluoride circuit breakers, its operation and maintenance. So in this discussion we'll take an example of ABB make SF6 circuit breakers. Its model is LTB245E1. Its mechanism is BLK222. Its rated voltage is 245 kV and it's single pole operations. So it's LTB means light tank breakers. It's suitable for breaking currents up to 50 kiloamps, and it has a very fast interruption of 2 cycles, and it is designed for system voltage up to 245 to 550 kV. That means it is 220 kV and 400 kV substation. It is suitable. Actually, we are using sulfur hexafluoride gas for the arc quenching medium. It has a high dielectric strength, excellent arc quenching ability. Next, a good thermal conductivity. In terms of physical and chemical properties, it is chemically inert, is non-toxic, and is non-corrosive and non-flammable. And why we are using SF6 circuit breaker? The advantages are is very short arcing period, and it can interrupt much larger current compared to the other breakers, and no risks of fires, and is very low maintenance also required. So these are the advantages of SF6 circuit breakers. In terms of operation, there are two categories. One is called as gang operated circuit breakers, one is called independent pole operated circuit breakers. On the left hand side you will see 132 kV SF6 circuit breakers, and here it is a 220 kV circuit breakers. It is independent pole operated. In gang operation, the mechanism is common for all the poles. It is R phase, Y phase and B phase. So the mechanism like spring charging, that is tripping spring, closing spring, all mechanism will be common here, and it is internally connected to R phase, Y phase and B phase. So whenever there is a tripping or closing operation happening, automatically all poles will be gang operated or simultaneously operated. In the independent pole operation, you will find each phase you will find a independent spring charging mechanism will be there. Separate mechanism will be there. So here R, Y, B if you consider, then each phase you will find there are separate mechanism box will be there, and its independent pole operation is there. That's why it is called independent pole operators. And here the contact separation between, this is called the top pad, this is called the middle pad. So the contact separation during the breaker operation will take place in between the two, the middle pad and the top pads. More category of a breaker is called light tank and the dead tank circuit breakers. The light tank means the circuit breaker, so the switching unit is located in an insulator bushing which is live at the line voltage or some voltage above the ground. Whereas the dead tank circuit breakers is the switching or the interruption occurs within a tank at ground potentials. This is at arc potential or ground potential. And in light tank, the circuit breakers are cheaper. Actually, it is cost wise very cheap cost compared to the dead tank. It requires very less gas compared to dead tank, and also space wise it also requires very less space, whereas dead tank occupies more space. This is the advantages of that light tank circuit breakers. It requires very low maintenance, it requires less space, and it has a low resistive losses and low drive energy. Because early days or nowadays also in some substations you will find that pneumatic type mechanism will be there that occupy more space. It's additional compressor requires, and that maintenance also more, whereas in spring operated circuit breakers of SF6 circuit breakers it requires very less maintenance, and it also requires very less space also. And it's also light tank type circuit breaker. Its SF6 gas leakage rates are very less because the quantity of gas is very less in this case of light tank circuit breakers, whereas in dead tank it occupies more space and it requires more gases. This is example of dead tank circuit breakers. This is ABB make 362 to 420 kV rated dead tank breakers. This is the actually tank that which is located at nearly ground potential. So this tank is located near to ground potential, that's why, and it requires more space, and also gas also required more. So this is the interruption chamber. This is R phase, suppose Y phase, this is B phase. This is the interruption chamber, and it has a bushing city will be there in the incoming side and outgoing. One more picture, it will be clearer. Here you can see very clearly, this is the interruption chamber which is located at the ground potential, and this is suppose incomer side, this is the outgoing sides, and the interruption will take place inside this tank. And this is called the bushing city. In the incomer side or outgoing side it is installed, where it is utilized for protection and metering. This bushing city is utilizing for metering and protections. And that tank also some advantages, like it is utilized for line, transformer, reactors and capacitor switching. Is a point of on wave switching also it is utilized, and high seismic application where which area or which location are more prone to earthquakes. In that cases that type circuit breakers are suitable. And also it is advantageous for high altitude applications where hilly area, if any substation or any station is there, then this type of circuit breakers are more stable compared to the live tank circuit breaker, because the live tank circuit breaker entire weight is on the top side above the ground, whereas in the dead tank entire weight will be on the ground level, so it is more stable. So the discussion we are doing in this topic SF6 circuit breakers, we have taken a LTB ABB make LTB 245E1 model circuit breakers. It's called LTB, means live tank breakers, and it has a voltage range of 245 kV. That is actually it is installed in the 220 kV substation, but the system highest system voltage can go up to 245 kV. So it is designed like 245 kV. So this is the gas SF6 gas specifications. What are the pressure, what are the filling pressures, all these things are mentioned here. This is the power frequency withstanding voltage, it is 460 kV is given. So breaking current is 40 kiloamps, making current is 100 kiloamps, exactly 2.5 times the breaking current. So one more is called the power frequency withstanding voltage. This is the RMS value of the sinusoidal power frequency voltage that the equipment shall withstand during the time of test under specified condition for a specific time, usually not exceeding 1 minute. This is the highest system voltage rating, that is I told you this is 220 kV. We can go up to highest system voltage can go up to 245 kV, whereas the minimum or the lowest voltage can go up to 192 kV. These are the range of voltage for 220 kV substation. For 400 it will be 420 and 380 kV. For lighting impulse withstanding voltage is the for 220 kV substation is 950 to 1050 kVp kilovolt peak, and it's 400 kV it is 1425 kVp. And the mention in the nameplate details, SF6 gas pressures, it is maximum working pressure will be 9 bar, and filling pressure will be 7 bar, signaling pressure is 6.2 bar, and blocking pressure will be 6 bar. Signaling pressure means it is the alarming pressure. Blocking pressure means breaker will be lockout. So breaker cannot do breaker operation during the time of locking of breakers. Breaker will be lockout. One is called as breaking current, one is called as making currents. Both are important from the design point of view of circuit breaker contacts. The material going to be used. Breaking current refers to the RMS value of the fault current at the instant of contact separations. And in this model of breakers we are discussing 40 kiloamps given as the breaking current. One more point is called as making current. It refers to the maximum peak value of the fault current, and breaking current refers to the opening of breaker contacts during the time of faults. Making current refers to the closing of breaker contacts during the time of faults. So whenever there is a fault persists and the breaker is closing, in that time, as the breaker is closing under fault conditions, so the breaker contacts should tolerate that mechanical or thermal stress during the time of faults. So making capacity or the making current always given as in the form of 2.5 times the breaking capacity or the breaking current. So technical specification of this particular breaker is the closing time is 28 milliseconds and its opening time is nearly 17 plus minus 2 milliseconds. There will be 2 tripping coil, 1 closing coil, so close will be less than 28 milliseconds and tripping or the opening will be 17 plus minus 2 milliseconds. Close open time is 20 seconds plus minus 3 milliseconds. And the motor charging, that is the spring charging motor, will take 15 seconds to charge the closing spring. Closing spring is one more important point, is the spiral type. The main contact resistance is 49 micro ohm and the main contact stroke is 160 plus minus 3 nms. Closing and tripping coil resistance will be nearly 240 ohm and circuit breaker auxiliary contacts, there will be 12 NO and 12 NC auxiliary contacts provided, and it follows the IEC standard 62271-100. The breakers we are discussing in this topic is the ABB make LTB 245E1. That this is the tripping spring. This is a helical type spring. It is kept inside a cylindrical enclosures and the mechanism is connected to the one more neighboring mechanism box. This is the closing spring. This is spiral type closing spring. This is the model type diagram. This is the actual photograph. The closing spring will be here on the installed here. This is the motor for the spring charging motor. Here NONC contact will be there, 12 NO and 12 NC contact will be there. So in terms of maintenance, the 2000 mechanical on-off operations, we require lubrications, and preventive maintenance can be performed after 5000 mechanical on-off operation, and overall in record after 10,000 mechanical on-off operations. Today we'll see the practical aspects of SF6 circuit breaker. So we are entering into the 220 kV substations. We are utilizing here that ABB make SF6 circuit breakers. So let us see what are the different components inside the marshalling box and what are the details of the mechanism inside that breakers. So this is live tank breaker. It is independent pole operated. So each phase you will find one breakers. So you can see this is R phase, Y phase and this is B phase. So in each phase you will find 3 breakers. So it is independent pole operated breakers. So we'll see inside marshalling box, but before going that we'll see the nameplate details. Already it is theoretical part, we have already discussed those things. Highest system voltage will be 245 kV here because 220 kV that allowable highest system voltage is 245 kV. In 400 kV it will be 420 kV. Sequence is open, then 0.3 seconds, then again close open to close open 3 minutes. This type of sequence is suitable for auto reclosure of circuit breakers. Each pole or independent pole operated circuit breakers, so you will find each phase one circuit breaker is there. So this is called as the middle pad and this is called the top pad. The contact separation during breaker operation, whether close or open, fixed contact and moving contact operations, or the contact movement will be happening inside this portion, top to middle portions. This is the mechanism box. This is the mechanism for B phase, Y phase, and I am standing in the R phase. So each phase you will find one mechanism is there. So now we'll see the gas monitoring device for this breaker. So this is the gas monitoring device, and for any type of gas spilling, utilizing that gas spilling kit will come. Using that kit we have to refill the gas here, either commissioning time or whenever there is a leakage of SF6 gas is there. So this is the all green zone is called safe zone. That means whenever the pressure above maintaining 6.2, there is normal operation we can do it. Whenever the pressure will reach to 6.2 bar, automatically alarm will come. So we have to arrange for the refilling of gas. And 6 means breaker will be lockout. This is the red zone. In this zone we cannot do the operation of breakers. Breaker operation not possible in the red zone below 6 or 6. 6 will be the lockout pressure, 6.2 is the alarming pressure. So these are the components inside the marshalling box. These 3 white color indication is the spring charge indication. This is breaker on, breaker off, and this is the breaker operation counter. And these 3 are K3 actually. This is anti-pumping relay. K7, K8 it will come as that pole discrepancy relay. For that timer is there, 3 seconds that timer is there. And this K10 and K11 will be the gas supervision relay. And apart from this there will be 3 capacitance will be there. You can see here. This 3 capacitance will be there. This is called as DC fail capacitance strip. So whenever that breaker DC supply fail, this is actually we are utilizing here 220 volt DC. So due to some reason, if there is a failure of DC supply, immediately the breaker will trip. So this is the function of that capacitance strip. This is suppose a generator bay, and if generator is running, and in the meantime this circuit breaker DC supply failed, and in this scenario suppose there is a fault happening in the generator, then the generator protection relay will extend the trip command to this breakers, but it will not trip due to failure of DC. So in that case that breaker is not going to trip in the fault conditions. So the fault may extend to some other area, LBB may be initiated, and some other breaker going to isolate the fault. In the meantime equipment might have damaged. So this is the reason this capacitance strip is there. Whenever there is a DC failed, immediately the breaker will be tripped. This is the utilization of this capacitors. This is 1000 microfarad, 3 capacitor given. Now we are going to do close operation now. Trip it. This is the emergency lever given, so mechanically we can trip the breakers. So this type of one lever will be there. If you pull it, automatically the breaker will be tripped. If one pole tripping means automatically remaining pole going to trip. This is the emergency lever that will be directly connected to the breaker tripping coil mechanism itself. So it is not electrical, this is a mechanical type operations actually. This is the spring charge indication. When the spring is fully charged, the pointer will come down here, and whenever spring is discharged, it will come to off. So this is the inside mechanism of the circuit breakers. So here it is off indication is there, and here the cylindrical enclosure is inside this cylindrical enclosure. Tripping spring will be there. That will be connected to here, and here top side that mechanism will be connected, and the same times here mechanism is connected through this rod. This is the rod, and this is actually particularly this is called as the closing catch gear, this portion, and this is called the opening catch gear. This part, this is called the opening catch gear. These two are the tripping coil. This is one and this is one more is, this is called a tripping coil, and this is the closing coil. And bottom side I shown you that one emergency trip lever is there, no, that is connected through this mechanism. So it is, once it is bottom side somebody pulling it, means automatically this will press and trip lever will be, the mechanism will be opened. So if the breaker is in closed condition, immediately it will open. This is called as the despot. So its function is to slow down the final phase of the opening operations. This is called as despot. And all mechanism here, it is connected internally. It is not so clearly visible, but I will show you once. Here actually it is connected through that tripping spring, it is connected. So inside this NONC contact will be there, that is 12NO, 12NC contact will be there. Inside spiral type closing spring will be there, and also closing spring charging motor will be there. The spring charging motor, closing spring, and the auxiliary contact will be there inside this. So this is the mechanism inside this breakers. And for spring charging it will take around 15 seconds time, and close and opening operation is close operation, it will take place within 28 milliseconds. Trip operation, it will happen nearly 17 milliseconds. This K7, K8 is the pole discrepancy relay. In case there is a mechanism issue or there is any closed coil issue, suppose one pole is not closed, in that case that remaining pole will be tripped. Suppose we given a command close to all the poles, so simultaneously it will close, but suppose due to some mechanical issue or closing coil issue, one pole or two poles not closing, immediately remaining pole will be tripped. That will be through the pole discrepancy relay. Presently all three poles are closed condition now. So it is visible or not? Yeah. Now this is the mechanical lever, that is called the emergency tripping lever. So if we open one pole by operating this lever, automatically remaining pole will be tripped. So I am tripping this pole now. B phase we are going to operate that emergency. So one pole will be open, means remaining two pole will be opened by the pole discrepancies relay. That we are going to test it now. So we are going to operate this one, the lever. Now you see this one is open now. So remaining two pole will be opened. Is already open now, you can see. Is off condition is there. This is the use of pole discrepancy relay. For this type of breakers, maintenance generally visual inspection required every 1 to 2 years. Every shutdown time we have to do the physical inspections, and that lubrications and required after 2000 mechanical on-off operations, and preventive maintenance required after 5000 mechanical on-off operations. Overhauling required after 30 years or nearly 10,000 mechanical on-off operations. This is the maintenance. So normally whenever there is a shutdown opportunity is there, we have to check the tightness of this middle pad and the top pad nut and bolts, and cleaning the bushing cleanings, that top and middle pads nut and bolt tightness, we have to check it. This is the maintenance. Normally we have to do it. Otherwise mostly it is maintenance free. In this type of breaker there is a manual spring charging option also there. If in case auxiliary supply failed for longer time, or there is a problem with the spring charging motor, then manually also we can do the spring charge. Below this mechanism box one cover is there. We have to open this cover and we have to insert that spring charging handle. While opening that plates, this limit switch will act. This will not allow the auxiliary supply to reach to the motor. So while opening that plates, the supply will be disconnected to this motor. This is the work of this limit switch. So manually also we can do the spring charge. To measure the coil resistance, we can directly measure here. This is closing coil. This is trip coil 1, trip coil 2. So here you can see here, this is the trip coil 1, trip coil 2, this is the closed coil. So the resistance will be nearly 240 ohms around. So I can open it like this. I open it like that, and you can see the resistance here. 234.7, nearly 240 ohms it will come resistance. So like that, trip coil, this is trip coil 2, trip coil 1 also we can measure it.